Welcome to Mr. Lehman's Knowledge Explosion. As we progress into Lesson 4, the purpose of this lesson is to understand angle measurements and the angle addition postulate. Before you get into this, it's a good idea to review some of your vocabulary. If you cannot define all the terms listed at the top of this page and find the midpoint between 2 points and the distance, then you need to review those things before moving on. But the main goal of this lesson is to understand what an angle is. And the definition of an angle is nothing more than two rays with the same initial point. So you can see in this diagram that both of these rays, ray BA and ray BC, start at the same point B and then extend forever in those two directions. We label an angle with those three letters. So we say angle A, B, C. So if you were to trace out those letters, A to B to C, everyone would clearly see which angle you're talking about. So make sure you label it that way. If you ever see an M in front of that, like M angle ABC, that's referring to the measure of angle ABC, which in this case is probably somewhere around 40 degrees. So make sure you understand that notation. In the next diagram, let's see if we can label all the angles that we see here. Right out of the gate, I see angle BAC. A lot of times you'll see me mark it this way so you can know I'm talking about that specific angle. I also see angle CAD, which is right next to that. Notice that I marked it with a different marking. I don't want to mark them the same because we learned last time that would mark them as congruent or the same, and I don't know that. I'm just talking about a different angle. So I also see angle DAE, which again I'll mark with a slightly different marking, or three of those marks to show that's the angle I'm looking at. Now many people would stop here, but you also have to see all other angles from that point A. There's also BAD, and angle CAE, and don't forget the big angle, which starts at B to A all the way to E. So there are actually 6 angles in this diagram that we need to be able to see. So don't just look at the 3 that are obvious, make sure you understand. Any angle is simply 2 rays that share that same point. And if you look at how I labeled all of these angles have A as that center letter. It's very important that you label angles with that initial point that they share always in the middle. So let's look at the next question here that says, if I were to put point F between points A and C, have more angles been created? So let's put in point F right here. And now I could say, well, there's angle BAF now in the picture. Is that really different from angle BAC? And the answer is no, it's not. If I traced out angle BAF and then I traced out angle BAC, it's the exact same angle with a different name. So you need to be clear on the labeling of angles and understand what's a different angle versus what's a different name for an angle. Much like once we learned what a line segment was, we could add up pieces of them with the segment addition postulate. The angle addition postulate says the exact same thing, only with angles. It says if point P is in the interior of angle RST, so angle RST would be RST, and point P is somewhere on the interior. This is saying that the measure of angle RSP, this angle, plus the measure of angle PST, the other angle, should equal the entire angle from R to T, the whole thing. So in other words, the 2 pieces of that angle should add up to equal the whole thing. Pretty simple idea. So let's look at an example down here in example number 1. It says the measure of angle PQR is 30. I like to trace that out. PQR is 30. And it says the measure of angle RQS, so R to Q to S, is 40 degrees. And now I can see that it's asking me for the measure of angle PQS. So if I'm looking from P to Q to S, I can see that everything in between is that 30 and 40 degrees, so it's simply 30 plus 40 equals the whole angle of 70. And that's the angle addition postulate. Remember, a postulate is something that's so obvious that we don't really prove it, we just accept it and use it as if it were true. Example number 2, same idea. Understand that I'll use the same picture for things, so you need to erase all the markings from example number 1 and start fresh with example number 2 with the given information. So we are given that PQR is 45 degrees, RQS is 20, SQT is 50, and TQV is 65 degrees. What I like to do now is just trace the angle I'm looking at. I'm looking for the measure of angle PQT. Well, that angle has 45, 20, and 50 all inside of that angle, so those three pieces will add together to equal the larger angle, which adds up to 115 degrees. I'll do the same thing for the measure of angle SQV, so SQV. That only has two angles making that, the 50 degrees and the 65, so 50 plus the 65 also equals 115. So that green angle and that pink angle are in fact congruent because they equal the same measurement of 115. We'll do the same thing for the measure of angle VQP. So we're going to trace out from V to Q to P. Now that ended up being a straight line, but it has all of these pieces in it, from 45 to 20 to 50 to 65. So remember, I have to add all of those together. 45 plus 20 plus 50 plus the 65, which equals 180. And I can see that's no surprise because we knew that a straight line always equals 180 degrees. And now we'll do our last angle here, which is angle RQT. So from R to Q to T. Well, that's only two angles, 20 and 50. So that 20 degrees plus that 50 degrees is a total of 70 degrees. So the angle addition postulate simply says I can add up the pieces of the angle to equal the larger angle and find those measurements. Very simple to do. Our third example, I need to mention a new word. We have the word bisect. And bisect simply means to cut in half or to make the angles congruent. And if I haven't mentioned it before, this symbol right here is the symbol we use for congruent. It looks like an equal sign with a little squiggle on top. So over here it gives me information. It says ray NO is bisecting angle MNP. So what I like to do is mark that. Bisect means that it cut this angle in half, or in other words, made those two angles congruent. So I put congruency markings on them. Well, the 3x plus 8 was angle MNO, and the 4x minus 9 was angle ONP. If those are congruent, that means they're the same, and if they're the same, then they have equal measurements. So I simply say that that 3x plus 8 has to equal 4x minus 9, and now I have a simple algebra equation that I can solve. So I'll subtract the 3x to get 8 equals x minus 9, and I add the 9 to the other side to get that 17 is equal to x. So if I was simply asking what x is, I'd be done, or I could always go back and plug that number in and say, well, this angle right here is 3 times 17, which is 51, plus 8, which is a 59 degree angle. And since these are congruent, this should also equal 59. So to double check, I could take 4 times 17 minus 9, and I do see that that's going to equal 59 degrees, so they're congruent. And they should be because I was told at the beginning that it bisects. See if you can do answer example number 4 and then check the answer with my answer key in the workbook. But what I'm more interested in is making sure that you understand the 4 classification of angles right now. There are acute, right, obtuse, and straight angles. And I'm sure you've heard of these, but I want to make sure you get the definitions. An acute angle is simply an angle that is between 0 degrees and 90 degrees. So this means we don't talk about negative angles. We always start at 0 and go up through 90. A right angle is exactly equal to 90 degrees, and an obtuse angle is greater than 90 degrees, but also at the same time less than 180. So we don't go above 180. And a straight angle, which a lot of people simply call a line, but when you're talking about an angle, we say it's straight, that's equal to 180 degrees total. So make sure you know those 4 angle definitions and the difference between them. And then the last thing we need to talk about is this idea of adjacent angles. Adjacent angles are 2 angles that share a common vertex and a common side. It does not simply mean they're next to each other. So if you look at this diagram that I have drawn for you here, angle MNO and angle ONP are adjacent. And it's because they share this common vertex N and they share this common side or ray NO. Since they both use that point and that middle ray, that's what makes them adjacent. So in our next diagram here, let's see if we can name a pair of adjacent angles. Angle RQS would be adjacent to angle SQT. So notice that when they are adjacent, they'll always have the same middle letter because they should have the same or shared point. So that would be one set of adjacent angles. You could also say angle VQT would be adjacent to angle TQS. Again, they both share Q and they both use this middle ray of QT. So make sure you understand those definitions. Make sure you can find measures of angles using the angle addition postulate. Work through the examples in practice lesson number 4 and see me if you have any questions. Good luck.